In the last couple of videos, we've talked about code generation for a simple programming language. And I mentioned at the end of the last video that realistic compilers do things a bit differently. And in particular, they do a better job of keeping values in registers and of managing the temporaries that have to be stored in the activation record. We're actually going to talk about both of those problems. In this particular video, we're only going to talk about the second one, and so we're going to be covering better ways for compilers to manage temporary values. So the basic idea, which we've already seen, is to keep temporaries in the activation record. Now, this is not as efficient as keeping temporaries in registers, but that's the subject of a future video. We're not going to talk about that today. What we're going to talk about is improving the way in which we manage temporaries that happen to be in the activation record for whatever reason. So it doesn't matter why we want them to be in the activation record, but given that they're there, what's the most efficient code that we can generate? And the improvement that we're going to make is to have the code generator assign a fixed location in the activation record for each temporary. So we're going to pre-allocate memory or a spot in the activation record for each temporary, and then we will be able to save and restore the temporary without having to do the stack pointer manipulations. So let's take a look at the canonical program for our simple programming language. Here is the Fibonacci function again, and let me change colors to something that has more contrast. And let's think about how many temporaries we need to evaluate this function. So this function body, when it executes, will need a certain number of temporaries. And if we know how many temporaries it needs in advance, then we could allocate the space for those in the activation record rather than having to do pushing and popping from the stack at runtime. So let's take a look. And if then else is going to involve a temporary, because in order to do this predicate comparison here, we're going to have to evaluate the first argument to the predicate and then save the result of that while we evaluate the second argument to the predicate. So this will involve one temporary. We'll need one temporary for that predicate. Similarly, for this predicate, to evaluate it, since it's a two-argument operation, a comparison, we will also need one temporary for that. And then there's this expression over here, which is kind of complicated. How many temporaries will we need for this? Well, remember how this works. So we evaluate the first expression, and then we save the result of that. So this will require one temporary for the result of the call to fib, because it has to be saved while we evaluate the plus. And now while we're evaluating the call to fib, though, actually before we evaluate the call to fib, we have to evaluate the argument to fib, and that involves a subtraction. So we also need one temporary here for this subtraction. Okay? And now, what about the second side of this addition here? Well, this also involves a subtraction. Okay, so we're going to have one temporary here to hold on to the value of x while we're evaluating the minus to compute the value of the argument before we call fib. Okay, so how many temporaries do we need in total? Well, we need one here for the predicate, but notice that once the predicate is decided, once we know the answer to whether this predicate is true or false, we don't need that temporary anymore. So in fact, that temporary can be reclaimed. We don't need the space for that temporary anymore by the time we get to the false branch. And again, once this predicate is evaluated, we don't need the space for that temporary anymore. Okay? So now we're down to the plus. The first thing that happens is we evaluate the argument to this first call to fib. Once that's evaluated, we don't need the temporary for it anymore. Now the result of fib has to be saved somewhere while we do the plus. Okay? And then we're going to have to evaluate the argument to the second call to fib. And now notice that this happens while we still need this temporary here. So in fact, we need both of these temporaries at the same time, okay? Because while we're evaluating this argument to the second call of fib, we still need to be holding on to the first argument to the plus. And so in fact, this particular function can be evaluated with just two temporaries. It's all the space we need to compute the value of this function body. So in general, we can define a function, nt of e, that computes a number of temporaries needed to evaluate e. And let's just talk about one example. Let's look at the number of temporaries needed to evaluate E1 plus E2. So that's going to need at least as many temporaries as E1. Okay, so if we need some number of temporaries k to evaluate E1, we'll have to have at least k temporaries to evaluate the whole expression. And then it'll also need at least as many temporaries as is needed to evaluate E2 plus 1, because we have to hold on to the value of E2 while we're evaluating, we have to hold on to the value of E1 while we're evaluating E2. Okay, and it's going to be the maximum over these two. So it'll be the maximum number, which between the maximum number of temporaries needed to evaluate E1 and 1 plus the number of temporaries to evaluate E2, that will be the total number of temporaries, the minimum number of temporaries needed to evaluate E1 plus E2. And the reason it's a max instead of a sum is that once we've evaluated E1, we don't need any of the space that was used to evaluate E1 anymore. All those temporaries are done. All we need is the answer. We don't need the intermediate results. And that means that the temporaries that were used to evaluate E1 can be reused to evaluate E2. So generalizing from that one example, here's a system of equations that describes the number of temporaries needed to evaluate every kind of expression in our little language. So let's take a look. So we already talked about E1 plus E2. It's just the max over the number of temporaries to evaluate E1 and 1 plus the number of temporaries to evaluate E2. So E1 minus E2 is exactly the same thing. It has the same structure. It's a different computational operation, but it's a binary operation, and we have to save the value of E1 while we evaluate E2. So it's the same formula. Now, for an if then else, well, what do we need? We need it's going to be a max again. It's going to be a max over some number of different quantities. How many temporaries might we need? Well, we might need as many temporaries as are needed to evaluate E1. We certainly need at least that many. All right, so if E1 takes a certain number of temporaries, the whole if then else is going to require at least that many temporaries. Now, of course, once E1 is done evaluating, we don't need its temporaries anymore. And then we can evaluate E2, okay? And while we're evaluating E2, we have to hold on to the result of E1. So that's where the 1 plus comes from. So while we're evaluating E2, we need 1 plus the number of temporaries to evaluate E2 to hold all the temporaries of the computation. And then once the predicate is done, we don't need any of those temporaries anymore at all. And we're going to evaluate either E3 or E4. And so then we just need however many temporaries each of those requires. And whatever the maximum is over these four quantities, that's the minimum number of temporaries we can get away with to evaluate the entire if then else. Let's take a look at a function call. So the space needed for a function call is the number of temporaries, the max over the number of temporaries to evaluate any one of the arguments. And this is actually an interesting case because notice that we don't have anywhere in this formula space for the results of E1 through En. Of course, once we've evaluated E1, then we need to save it somewhere. And so you would think that we might see some numbers in here representing the temporary space needed to hold on to the results of evaluating each of these expressions. And the reason we don't have that in here is that even though those values are saved, they are indeed saved, they're not saved in the current activation record. The space for the result of E1 and the result of any of the arguments, EI up to EN, is saved in the new activation record that we're building. And so the space for the results of E1 through En, those values are stored in the new activation record. They're not stored in the current activation record. And we're trying to compute the number of temporaries needed to evaluate inside of the current activation. And then for an integer, that doesn't take any space at all. It doesn't require any temporaries, so there's 0 temporaries required for that. And also for a variable reference, those require no temporaries. So now let's go through our example and work out systematically using the equations how many temporaries we will need. Okay, so here, for this if then else, remember, it was going to be the max over the number required to evaluate E1. Well, that's 0. 1 plus the number to evaluate E2, which is the second expression in the predicate. So that would be 1, because the number 1 requires 0 temporaries, and we have 1 to hold on to x. Okay, and then the max over the branches. So to evaluate 0 requires 0 temporaries, and now we have to compute the number required here. Okay, so once again, to evaluate the first expression in this if-then-else requires 0 temporaries. To evaluate the second one will require 1 plus the number required, 1 plus 0. To evaluate that constant will require 0 temporaries. And now for the last expression, how many will this one require? Well, this is going to require 0 for this guy, 1 for the second argument. So to evaluate fib is going to require 1 temporary. Okay, and then it's going to be 1 plus over here. We have to hold on to the result there. The value of x minus 2, so what's that going to require? Well, that's going to require the max of 0 and 1 plus 0. Okay, so this will be 1. All right, so we have over here, we have 1 plus 1 is 2. Okay, and now we're taking the max over 2 and 1. So that's 2. Okay, and this is the last expression in the outer if-then-else. So clearly this if-then-else here will require 2 temporaries. Okay, because that's the max over the number required for either part of the predicate, the then branch, and the else branch. And now this whole expression requires 2 temporaries, and that'll be the max of the 4 components of the outer if-then-else. And so then for the entire expression, we get 2 temporaries. Once we've computed the number of temporaries required to evaluate a function body, we can add that much space to the activation record. So now our activation record is going to require 2 plus nt of e elements. And so the 2, of course, are for the return address and the frame pointer. The n is for the n arguments to the function, and then the rest of it is just the space required for the temporaries. And now we can talk about how we're going to lay out the activation record. We'll leave the first part of it the same, so everything up to the return address is laid out just as before. First the caller's frame pointer, then the n arguments in reverse order, and then the return address. And then after the return address come the n locations, or the nt of e, locations for the temporaries.